me start the recording. So for the 11 o'clock session today in room 2, we have supporting STEM learning in young children with Jennifer Sullivan from the Anderson Public Library. So without further ado, we will go ahead and get started. And Jennifer, it is all yours, so you can take it away whenever.
All right. So as she said, I'm Jennifer Sullivan. I'm the children's librarian at the Anderson Public Library. And I think I'm coming down with a cold, so if my voice gets a little hoarse or scratchy, please forgive me. So my session is about supporting STEM learning in young children, but a lot of the concepts and even some of the activities will also work for elementary ages. So if you work primarily with older kids, it still might be worth sticking around. So I'll tell you a little bit about my background. I've been at Anderson County as a children's librarian for 3 years now. I worked for several years in the Lexington Public Library before that. But librarianship is a second career for me. I actually started out in the STEM field. My undergrad degree was in biology and chemistry and secondary education. I have a master's degree in microbiology, and I worked in vaccine research and development for a few years. Then I took a long stretch of time off to be a stay-at-home mom, and when I was ready to go back to work part-time, I ended up landing in libraries and fell in love with it. So I love using all of my varied interests and experiences in programming. But you do not have to have a STEM background to do STEM programming, especially with the younger kids. The concepts and things you're working on with that age, you don't need advanced science education. So don't let that intimidate you at all. So I think everyone now probably knows that STEM stands for science, technology, engineering, and mathematics. This acronym was originally coined in 2001 by the Director of Education and Human Resources at the National Science Foundation. But what you might not know is that the original acronym was SMET, for science, math, engineering, and technology. But the Director of Education and HR at the Science Foundation didn't like that acronym. She didn't like the way it sounded. It wasn't as catchy, and it probably sounded a little too much like smut. But actually, the original acronym better represents the relationship that these fields have with each other. So that's kind of the order I will go in, because science and math are the basics, and then you build on those to get engineering and technology. The science is the study of the physical and natural world. So that's your basics, biology, chemistry, physics, earth science, astronomy, all of those, and then all the various subsets. Then math is the study of quantity in space, not outer space, but space as in spatial relationships. So there you have your addition, subtraction, multiplication, division, algebra, geometry, trig, and calculus, which obviously we're not going to be teaching advanced trig and calculus to preschoolers. And then you apply science and math to get engineering. So engineering is using science and math either to build things like bridges or buildings or machines, or to manage processes. Like, for example, my husband is an engineer with Columbia Gas, and he manages the flow of gas through the pipelines to be sure everybody has natural gas when they need it. There are also engineers that manage the flow of traffic. You might think some of them could do a little bit better job, especially when Keeneland is running and you need to go to Lexington. And then, so engineering builds the machines, which is our technology. So you apply all three to build machines, to do the work for us. So anything that is any type of a tool that we're using to do work for us or help us do work is technology. It's not just computers and coding and robotics, which is what people tend to think of. It's also things like sewing machines or simple machines like levers, ramps, pulleys. That's all technology. Your vacuum cleaner is technology. The wheel is technology. So you have to keep in mind, all the low-tech technology, especially with working with kids. Everything's not high tech. So STEM started out at the government and university research level, and then it trickled into colleges and undergrad, and then into the public schools and high school and down lower, and it migrated to libraries, and so now it's trickling down to the younger ages. So what does STEM for, say, toddlers and preschoolers look like? Does it look like this? Are we teaching babies to code, expecting toddlers to do advanced microscopy, having preschoolers mix dangerous chemicals? It's like, no. Oops, my thing did not show up. Okay. Don't know what happened. That's supposed to have a big red X through it. So this is not what we're looking at. We're looking at age appropriate. So for basic science, so earth science is like rocks, dirt, fossils. Biology would be, animals, bugs, different flowers, learning about vegetable gardening. Then physics is just simple things like playing with magnets, prisms to see the light spectrum. So it's things that are at a developmentally appropriate level, and they're sometimes so simple that people don't even realize they're supporting STEM concepts. So now we're being asked to provide support STEM learning for younger kids. So does that mean we have to add even more programs to our already full plate and stretch budgets? And no, it doesn't. There are many ways to support STEM learning within the framework of existing programs. But of course, if you have the staffing and time and resources to add specific STEM programs, by all means, go ahead. You can do both, and that's even better. But a lot of the things that we already are doing can support STEM. And this is because children are born scientists. They're hardwired to explore. They're naturally curious. It is easy to include STEM elements in other programs, and a lot of the things we already do can support STEM. And it's all about the approach and mindset. You just might have to be a little more intentional about it, and you might have to make the connections more obvious for, caregivers as well as other library stakeholders and management. And I meant to say at the beginning, feel free to chime in the chat with questions at any time. I'd rather have a little more interaction than just feel like I'm talking at a screen the whole time. So go right ahead, and any that I miss will catch up at the end, but feel free to put them in at any time. And I've realized this, that you do kind of have to spell out the connections for caregivers more obviously just recently. Our library has been hosting the Science and Play to Go exhibit from the Kentucky Science Center, which is a great thing. I highly recommend you do that if you get the opportunity. And as part of that, they have a survey that they ask parents and other caregivers to take. And some of the results were all very positive. Some of the things that parents have said is, oh, we would love to see, some of this stuff at the library all the time. We'd like, more science programming for our kids. And like my assistant turned to me and said, it's funny that they keep asking for that when I've seen you do all these kinds of activities in programs since I've been here. So, if you don't have a big sign on it saying it's science or that it's STEM, they don't always recognize it. So just as we have to kind of give tips for supporting early literacy skills in story time, you kind of have to spell out some of those connections, because parents are kind of aware of terms like STEM and STEAM, but they don't always recognize it when we're doing it. So you may need to spell that out more. So if you're embracing a STEM mindset and you're facilitating and modeling STEM with a group of kids, these are kind of some of the things you might hear. So you're going to be hearing open-ended questions, asking how things work. What happens if I do this? You know, why did this happen? Well, how can I make it do what I want? What do I need to change? You'll see expressions of wonder and curiosity. You know, oh, I want to try that. That's amazing. That's so cool. So this is the kind of environment we want to foster. And so a STEM mindset is a growth mindset. You may have heard that recently. It's been kind of a buzzword the last few years. So it really just means that you're open to learning and trying new things and considering new possibilities and information, that you don't have a fixed mindset and fixed opinions about things. So with a growth mindset, you're modeling and facilitating wonder and curiosity and exploring things, encouraging open-ended questions, that, you know, the what, the how, the why, the what if, encouraging and modeling, making observations of their environment and noticing all the little details, testing their ideas and problem solving when things don't work. So these are all part of a growth mindset or a STEM mindset. Now the STEM mindset in action is the focus is on the process, not the product. And this is a mantra I repeat a lot in my programs because caregivers are often more fixed on the outcome than the process. So even when we're doing a typical craft, especially, they tend to focus on the product. So you have to remind them over and over, the focus is on the process, what we're learning by doing, what skills we're exercising during the process. There's no such thing as failure. When something doesn't work, that's an opportunity for critical thinking and problem solving. So if you're doing an experiment and it doesn't work, that's not the end of the world. You try to figure out what happened. Maybe you didn't measure something right. Maybe you need to add a little more of something or do something a little differently. If their building falls down, it's not the end of the world. They can rebuild it and they can think about, help them kind of problem solve and talk them through thinking about why it fell, how they can build it different to make it more stable. Encouraging that curiosity and exploration and wonder in the environment, and model asking those open-ended questions, because you're modeling it not only for the children but also for the caregivers, so they can do this at home just like we model early literacy skills. And the other thing is to let kids do as much themselves as possible. And that's one thing I've noticed in the last few years, is that caregivers are very reticent to let the kids do things, especially using scissors. Even though we have blunt-ended safety kid scissors, caregivers don't want to let kids cut. They are too worried about things being done right or don't think the kids can do things. So really trying to encourage them to do as much themselves, like letting them cut, letting them measure some things themselves. And then another thing is making sure that you're always presenting scientifically accurate information no matter what kind of activity or programming you're doing. So these are my two pet peeves. We don't want to see 4 8-sided snowflakes. Snowflakes are ice crystals, and the physics and chemistry of the crystallization of water dictates that they always form 6-sided crystals or 6-pointed. So if, for example, I saw one trying to turn an art activity into a STEM activity, and it was using cotton swabs to create snowflakes on paper. and she was trying to make it a STEM activity by talking about the symmetry of snowflakes. So they were on the right track, but then the example they showed had 4 points. So when you have that inaccurate information, it kind of negates any STEM value. Another one I see a lot is polar bears and penguins together. So if you're presenting, say, an Arctic themed story time, well, the Arctic is not just a general term that means cold, it's actually a specific region on the Earth in the Northern Hemisphere. And polar bears are found at the North Pole in the Arctic area. Penguins are only found in the Southern Hemisphere. So you're not going to see them hanging out together. And if you happen to read a story, of course, we have a lot of picture books that have anthropomorphized animals and show predators and prey being best friends. So obviously there's some artistic license there, but you can point out some of those things. But again, just trying to be a little more mindful. If you're talking about an animal and its habitat and things, maybe just do a quick check to be sure that you have the right information. So now I'm going to talk about some different ways of incorporating. Good job, Elizabeth. Yeah, that's one thing I always bring up in any of my STEM talks. So I'm on a mission to educate everyone that snowflakes are six-pointed and polar bears and penguins do not hang out together. And if they did, the polar bear would eat them. But now I'm going to show some ways of incorporating STEM elements or STEM concepts and STEM thinking in programs, and then I'll get into some specific actual STEM activities. So doing things like asking them open-ended questions about anything, about the story you're reading. Any kind of open-ended questions is encouraging that STEM mindset and STEM thinking. Asking them to make careful observations of anything, of whatever they're playing with, of something they see outside, something in a story during story time. What color is, this, and what do you see? Making predictions. Of course, we're not using crystal balls. That was the best image I could find to represent making predictions. And again, it doesn't have to be in terms of something happening as part of a STEM activity. It could be in terms of what they think is going to happen next in the story, but it's just that kind of thinking. And then using questioning, observation, predictions, and testing to figure out the answers, or using nonfiction books, doing research to find out the answers. And again, introducing and incorporating nonfiction books in story time is a great way to add some, science facts and information, and that all helps to support STEM. Sensory exploration is another great way. We do a lot of different sensory things. We have sensory tubes and balls of various kinds for the littlest ones. I have a sensory bin that was probably the best $300 or so I've ever spent. They love that. We put a lot of different things in there. We'll have water, we have a magnetic fishing set, or I have frogs and lily pads. We'll just put a bunch of different measuring cups and spoons in the water, boats and rubber ducks, so all kinds of things. Sometimes we use water beads. I don't use those very often now that there have been so many safety concerns brought up with those. I'm trying to figure out a safe way to use those because they like them so much. But shredded paper, rice and beans, sand, kinetic sand, there's all kinds of things you can kind of use as a base and then put different elements in it for them to find, or just scoops, measuring cups and spoons. And then for an example, so this all supports basic science. It's giving them all that stimulation, exploring the different textures and sensations. it helps build those brain connections as they're developing at that age. And then also, you see they are using tools for some of it. They're using scoops and buckets and shovels and measuring cups. So that is technology at a toddler and preschool level. There's another activity you probably incorporate in your story times and other programs for this age group. Any kind of building, stacking, putting things together. So that's engineering, that's exploring those spatial relationships. So if they're stacking 2 blocks together, they're engineering, and then when they knock it down, for one, they're learning that they can make things happen, and that's a big thing for them. They're learning cause and effect. So even all these little things we might not think of all support STEM, and they're exploring STEM thinking while they're doing it. And there are a lot of different things you can use. We have many other manipulatives and building sets besides these. If you, Lakeshore Learning is probably one of the best sources. They have all different kinds of building things. So like here we have foam blocks and cups and the giant mega blocks. You'll see the little boy in the right corner those are fish shaped building pieces. There's also bunny builders, star builders, some tubes and things. They have all kinds of stuff that are really great, and you can rotate them out. Yes, Magnetiles are a huge hit with all ages. We keep those out on our floor all the time. So all of those things are great. Okay, and then these are some examples of incorporating math, and these are things that you probably do frequently in Storytime or other programs. If we do a lot of the counting rhymes. So if you're doing, for example, a counting up rhyme, so you have one whatever, and then along comes another one, and now you have two, and two whatevers are doing whatever, and along comes another, and now there are 3. Well, you're doing addition. And if you're counting down, that's subtraction. Sorting things by color, size, or other characteristics is a great math activity, as well as pre-science, because classifying things is a science activity. And if they're small things, they're also working their pincher grasp, which is great for writing later. Playing with various of shapes, the magnetic numbers, measuring things, so letting them use rulers, measuring tapes, balance scales, all kinds of things. And on my blog, which I will give you the address for later, I have a whole article on incorporating math in Storytime. And then finally pointing out the scientific process involved in other things like cooking, art, and some of the examples here are like I've done butter making, which is a huge hit. People love it. It's a big hit with the homeschool crowd in particular. So you can make it a science activity as well by talking about how the butter is formed, how the shaking it causes all the little globules of fat to come together, and how the fats are hydrophobic, which means they don't like water, and that's how they separate out from the liquids. If you're making slime, which is a huge hit, I don't do it with toddlers or preschoolers, but with the elementary and middle school ages, they love that. That can be a STEM activity. If you talk a little bit about how the glue is a polymer, and whatever agent you're adding, it all boils down to borax is causing the polymers of glue to link together so they can't slip and slide as easily. The other example is an art activity, doing resist art. So you can make that have a STEM element by talking about how that works, how the wax from the crayon. And by the way, be sure you don't use the washable crayons for this activity, because that doesn't work. You have to have old-fashioned wax crayons or even just a wax candle. But the wax works because it's hydrophobic, so when you paint over it with watercolors, which are water-based, it repels it, and that makes your design show. And when this particular example, going back to snowflakes, you can add even more STEM by talking about the symmetry and why they are six-pointed. And then another way is when you do any of the multi-station programs or a party program, just be sure you throw in one or two STEM-based activities, and that's a great way to add more STEM to your programming. And now I'm going to get into some specific, more what I would call hardcore STEM activities. And I do have handouts that list ways of incorporating all these elements that has a little more detail, and as well as some of these activities and things that you can email me later and I can send them to you. Okay. Oh, forgot about this one slide. So also, if you do any kind of community helper or career fair type programs, being sure you invite people from STEM careers and think outside of the box a little bit. The obvious ones are working in computers, robotics, doctors, but there's also things like, engineers, and there's many different types of engineers, veterinarians, zookeepers, wildlife biologists, mathematician, people who teach the STEM fields. So you can bring those in and let kids see that there is a wide array of STEM fields, and it's all not just about computers and technology. All right, now we'll get into our activities. So to start off with, baking soda and vinegar are your best friends, especially if you're on a tight budget. They are cheap, especially if you can buy them in bulk from someplace like Costco or Sam's. There are so many different experiments and variations you can do, and they never get tired of it. You can put the baking soda in a balloon and carefully put the balloon over the top of a bottle with some vinegar in it. And then when they lift up the balloon to let the baking soda fall in, it will react and release the gas that blows up the balloon. There's the old volcano experiment, which you also add a little bit of dish soap and food coloring, and you have a volcano. There are ways to use it to make a jet-propelled boat or car. You can make a paste out of the baking soda and hide something in it and use the vinegar to reveal the treasure. You can also use the same kind of paste to build a snowman, and then you can use vinegar as acid rain to melt your snowman. One thing I like to do in October is we do a puking pumpkin, which is basically a variation of the volcano experiment. You carve a jack-o'-lantern face in a small pumpkin and put baking soda, a little bit of dish soap, food coloring inside, and then when you add the vinegar, the foam comes out the mouth, and depending on how much you use, sometimes out the nose and the eyes, and the kids love that. For New Year's one year, when I was in Lexington, my coworker did a New Year's Eve program, and one of the activities was bubbling champagne flutes, where we had the little plastic champagne flutes with baking soda and gold confetti in. You add a little bit of vinegar and it all bubbles up. So that there are many other things you can do with it. So that is a staple in my STEM supplies. Sink or float is a common experiment that people do with toddlers and preschoolers, and you can scale it up to elementary depending on how complex you make it. For the younger ones, you can just get a bunch of different objects and let them explore the objects, and then let them predict whether they're going to sink or float, and then test it and see what happens. With a little bit older kids, you can give them a piece of aluminum foil and let them try to design a boat that will float and hold weight. Pennies are a convenient thing to use. There are other things you can use. And so I did that with elementary ages, and they really got into that and trying various designs to see how much weight they could get it to hold. There are also some nice little kits. You don't need these, but they're kind of nice that also come from Lakeshore Learning. And no, I don't get kickbacks from them. I just really like their products. But they have a simpler one and a more complex one that come with a lot of different things, and they come with activity cards that give you suggestions. So if you have the money to spend on that, that's nice to have, but you don't have to have it. And I'm going to start going through these a little faster, so be sure we have time for questions. So Explore a Pumpkin is doing basic scientific observation, and you can do this with anything, but I did this as part of an overall pumpkin science program. And at this station, it was really good for the younger siblings that came. So I had various types of pumpkins, all the smaller ones, different colors, different sizes, shapes, and textures. And then on the sign, I had different prompts of what to do. They could put them in the large container of water to see if they sink or float. They all float, but kids don't know that until they try it. Measuring tape and rulers to measure their circumference, how big around they are, how tall they are, the diameter across, a scale to see how much they weigh. Then I had one cut in half so they could see the internal structure. And then I had the guts. I had some in a bowl just out in the open for the ones who were really brave to get that textural exploration. And for the ones who didn't want to get dirty and messy, I had some sealed in a bag so they could squish around. And you can do things like this with a lot of different things, not just pumpkins. Cornstarch is another cheap thing that is your friend. You can use it to make oobleck, which is a non-Newtonian fluid if you put low energy into it. So for example, if you're just holding it in your hand, it will run out of your hand like a liquid. But if you squeeze it hard, it will feel like a solid. Or if you slowly poke your finger into a dish of it, it's like a liquid and you can stick your finger in. If you slap it hard with an open hand, it will feel like a solid. So that is fun to play with. You can color it. And of course, there's the Dr. Seuss book, which gave it the name Oobleck. You can always pair with it for a literacy connection. Another thing, so some people call it slime. A slime is generally using glue and some type of borax. So Ashley is asking how oobleck and slime are different. So slime is basically using glue and a catalyst or another reagent, which is always some form of borax that cross-links those. And it is really generally sticky unless you use a lot of glue. The oobleck is just cornstarch and water. And a lot of people will refer to oobleck as slime or toddler safe slime, but to me they are different. And then one cool thing you can do with oobleck is make a dino dig that is great for toddlers and preschoolers. You know, the dino dig kits that you purchase are made with plaster, and I'm sure many of you have experienced how difficult they can be to excavate and how frustrating they can be, especially for younger children. So I found a way to make an easy one that is perfect for like toddlers to preschool. So you just pour your oobleck into a container and then get some of the little plastic dinosaur skeletons and push down in it and let it dry out. I can't really say how long it takes it to dry out because when I did this, I was in Colorado where it's very, very dry. So it only took overnight. It might take longer here and might be a little weather dependent. So this is something you would definitely want to test out ahead of time. But once it's dried out, then you turn it out of the container and give them some tools, and it's very crumbly, and they can easily do that. So even a 1-year-old can do it, but you would want to watch them closely to be sure they didn't eat it, although it wouldn't hurt them, but it would be gross. And then another activity to go along with that is making your own simulated trace fossil using salt dough. So I forget the recipe. I think it's maybe 1 cup flour, 1/2 cup salt, 1/2 cup warm water. There are variations that have lotion or conditioner or oil in it. You don't want to use that for this activity. You just want the straight flour, salt, and water. And they can use plastic dinosaurs to walk through them and leave trace footprints, or they can push them down to get impressions of their skin texture. You can imprint shells and plants and other things, and then they can take it home to bake it, because it has to bake at like 200 degrees for 2 to 4 hours, depending on how thick it is. So I've done that several times. Candy science. So you just basically pick different candies. You can see how quickly they dissolve in various liquids or various temperatures of water. If you put conversation hearts or pop rocks in Sprite, they will kind of dance around, float up and down. I did a Peeps tasting and torture program where first they tasted different kinds of Peeps, and then we did different things to them, like dissolving, putting them in the microwave. So that's always fun, and it can kind of tie in with around Valentine's Day, Halloween, or really any time. Bubbles are great. Blowing bubbles is great for tracking and reaching across the midline anyway, but they can experiment with different bubble wands and see if a square wand will make square bubbles. It doesn't. You will always get round bubbles. You can add paint to it and do bubble painting. You can put a sock over the cutoff end of a bottle, dip it in bubble solution and blow and make bubble snakes. So that's a fun one. And then this is one I've done for germs and teaching healthy habits. I have a little felt set with the hands and the different germs, and there's a couple of different rhymes and songs about hand washing to get rid of all the germs. I don't have a picture of it, but a fun activity to show how germs spread. I use glitter and put my hands in the glitter, and the glitter gets on my hands, and then I shake their hands and they can see how it transfers. I did this and they loved it, but I ended up with a bunch of preschoolers crowding around clamoring, I want germs, I want germs. So I'm not sure they quite got the concept. You can put confetti, smaller confetti than this shows, but small confetti, I just punched, did hole punches out of different colors of paper, put it in a balloon, and pop the balloon to simulate a sneeze. And then think outside the box and think about how you can apply a STEM mindset to make programs that aren't really STEM related into a STEM program. And I did this with gingerbread house building. So I've seen people do the little mini gingerbread houses using graham crackers, and a lot of times they will pre-build the house for them or give them empty milk cartons to build them on. I've even known of someone that hot glued the crackers together beforehand and gave everybody the exact same candy so it would all turn out and everybody's would look perfect. But again, we want to focus on the process, not the product, and have a little bit more faith in kids. They can do things. They can figure things out. So I did show them a basic building method, but I strongly encourage them to do their own thing, and these are some of the ones we got. So they were doing engineering and problem solving and designing their own and fixing things when they didn't work. So, and now some general tips. Remember, you want to highlight and explain the STEM concepts involved. Be sure you research in advance so you're presenting accurate information and explanations, and be sure you test activities in advance. Always test, because it will come back to bite you if you don't. And while you're testing them, that helps you be aware of what steps they might have trouble with, where there might be safety concerns. You want to invest in basic equipment and multi-use items. And I have a whole list of suggested items I can send you. Before purchasing any expensive gadgets, be sure you do your research and that they're appropriate for your intended age and goals. There are a ton of coding toys and things out there, and some of them are great, some of them are junk. So be careful with those. We want to, hands-on, play-based, experiential learning. That's been a big theme through a lot of sessions in this conference, I've noticed, and that's good to see. And high tech is often overemphasized for the younger kids. You want to stay with low tech and the basic science and math. And then some resources. Okay, this book I highly recommend. Baby Steps to STEM by Jean Barbre. Even though it says it's for infant and toddlers, the information is great for all ages, and a lot of the activities in it can be used for even older kids. It has a lot of information about brain development, how they learn, cognitive stages, developmental stages, and then it gives a lot of activities. It has lists of supplies and concepts. I can't say enough about this book. And here's an example of a spread for one of the activities. So they give you the suggested age. I would take that with a grain of salt. It really depends on your situation, what kind of STEM concept it is, learning outcomes, tips, materials lists, the directions, how to expand it, vocabulary, activities to do at home, examples of open-ended questions to ask, as well as book list. Now, this was published in 2017, so the book lists are a little bit dated, but they still might be helpful. There is a website, and again, you can either screenshot this or take a picture. I have a whole list of resources beside these. But this first one, Let's Talk, Read, and Sing About STEM from the Administration for Children and Families, is really great. It has tip sheets for both caregivers and teachers or librarians, facilitators, and in both English and Spanish. The second one is just about one person, some of the activities they do with their kids. And then the last one is my blog, Adventures in Storytime and Beyond. I have some articles about STEM programming in general, as well as write-ups as a lot of the STEM programs I've done. And then the best embodiment of a STEM mindset I could think of, Miss Frizzle. So take chances, make mistakes, and get messy. Okay, and then finally, here's my contact info. Feel free to email me, and there's my blog. You can also contact me through my blog if you want to talk more informally, and you can find me on LinkedIn. So I know it ran a little long, but if you have any questions, we can maybe get a couple in, and if not, please email. But that is it, and thanks for listening.
All right, Jennifer, thank you so much. That was wonderful.